Hi, this is the second part of section 5.2, properties of logarithms. In this section, we're going to expand on what we did with logarithms in the last lesson, and we're going to be using logarithmic properties called the product rule, the quotient rule, and the power rule. These three properties are going to be used in almost every single problem throughout the lesson, so it's really important that you have these written down in your notes. Beginning with the product rule. The product rule is a way to combine two logs together. These are going to be very similar in context to our exponent rules. And remember, exponents and logs, exponential functions and logarithmic functions are inverses of each other, which is why we're seeing a lot of similarities in this lesson. Combining two logs together that are added. This product rule tells us that we can condense the two logs together by multiplying the values within the log. Notice in both of my original values there was a log base A, and when it's condensed we still have a log base A, similar to when we had our exponent properties. When we combined with our same base, our base never changed. Off to the side here, I'm going to give you an example of what this looks like with numbers because sometimes it's a little easier to see. So let's say we had log base 3 of 5 plus log base 3 of 7. This property tells us we can condense these or combine them together by making it still a log base 3. That base of your log will not change. And then we're just going to multiply the numbers within the log together. So 5 times 7 gives me 35. The next property is the quotient rule. The quotient rule says if you have two logs that are subtracted, you can combine them together by making it a division problem, a quotient. For example, if I have log base 2 of 12 minus log base 2 of 4, I could combine those together and make it a log base 2, the base never changes, and then divide my numbers in the order they're given, just like subtraction, division, order matters. So 12 divided by 4 would give me 3, and that would be how I would combine those logs together. Finally, the power rule. The power rule is used in two different ways depending on what we're trying to do. It first says if we have a log of a number to a power, we can take that power and we can move it down in front of the log, or vice versa. If we have a number multiplied by a log, we can put it in the exponent. So for example, let's say I had log base 3 of 5 squared. This property says that's equivalent to 2 times log base 3 of 5. That power we're bringing down in front of the log. Okay, the video is going to pause real quick, give you a chance to make sure you have all this written down in your notes, and then we'll do some examples. Okay, the first way that we're going to use these properties is by condensing. Condensing is a fancy way of saying let's take all of our logs and put them into a single log if possible, using our three logarithmic properties. All right, so let's start with, we'll call this example number 1. In this problem, the only thing I have that applies to any of my properties is I have a subtraction between my logs. And our quotient property says that if I have two logs that are subtracted, that I can combine them together by making it a quotient. Both of these logs are the same base right now. We see no base written there, so you could say it's a base 10. These are our common logs. It's going to remain a common log. Again, if you want to put the 10 there, that's fine. And then in parentheses here, we're going to divide what we see inside our logs. So 3x over 4y. 3x over 4y doesn't simplify, so that would be your final answer. Number 2, I have 2 log base 2 of 5 plus log base 2 of 9 minus log base 2 of 75. The first thing we want to do is if we have a number in front of our log that's multiplied, we want to move it up into the exponent. So I have that 2 there. I'm going to move it up into the power. Now, right now, you could say 5 squared, or you could just simplify it. We know that 5 squared is 25. So we'll save ourselves a step and do that all at once. I'm going to bring everything else down. Okay. Next, if you have any addition, our properties tell us that we're going to multiply those logs together to condense them. So we're going to keep it a log base 2, and we're going to multiply 25 times 9. 25 times 9 is going to give me 225. And I'm going to bring down my log. There we go. And then finally, to condense these two logs together, I have subtraction. Subtraction again changes to division. So if we do 225 divided by 75, you're going to get 3. So log base 2 of 3 is our final answer. Let's look at the third one. Okay, again, first step, if you have any numbers in front, you're going to move them into an exponent. So I have here a natural log. It's going to be a natural log of x squared, which we can't simplify, plus natural log of, now I'm going to have x squared plus 1 to the 1/2 power. Remember, anything to a 1/2 power is the same as a square root. So we're going to write that square root instead of writing the exponent. So you might see a 1/3 or a 1/4. Remember those from when we did our radical lessons before, or cube root or fourth root. Anytime you see a 1 over a number, you're going to change it into a radical symbol and maybe put the root number next to it if you need to. Next, to combine these together, they're added. So my log properties say I can multiply what's inside the logs together. So it's going to be x squared times x squared plus 1. And then nothing else we can simplify there. So that's our final answer. And you could always put that in parentheses too if you feel like it looks a little nicer. Okay, let's look at the next one. In this one I have some brackets and a number out front. I've got a couple different ways that I can do this one. The first way I can do this one is I can kind of work from the inside out if you've got multiple sets of parentheses, which is what I'm going to do here. The other option is you could distribute the 1/2 into both the logs and then move it up into the exponent. Either way, you're going to end up with the same answer at the end, but I like to think about my order of operations and go from the inside out if I can. So I'm just going to bring that 1/2 down. And then the two logs on the inside are added, so we're going to multiply them together. So it's going to be log x plus 1, x minus 1. And now here we can actually simplify a little bit more. If I'm multiplying x plus 1 times x minus 1, that's a little foiling we can do. And if I FOIL those together, my first terms, x and x, are going to give me x squared. My outside terms, x and -1, are going to give me -1x. My inside terms, 1 and x. And my last terms, -1. The 1x and the -1x are going to cancel. And so now I have log of x squared minus 1. Okay. Finally, at the end here, I have this number in front of my log that I can move up into an exponent. A 1/2 power is the same as a square root. So we're going to have, actually let me erase that. So we're moving it up. So we're going to have log, and then my x squared minus 1 is going to have a big square root over it. And because of that subtraction inside the square root, there's nothing else we can do to simplify this. Now, if it was just x squared, we could simplify the square root and the x squared, but because you have addition or subtraction, in this case subtraction underneath the radical, you cannot simplify any further. So this will be our final answer. Okay, so here are a couple condensing problems for you to try. All right, let's see how you did. So in A, you should have first moved the 3 up, which gives me an x to the 3rd power. Then your logs are added together, which means you can multiply x to the 3rd times y. And that's your final answer. Again, if you wanted to put that in parentheses there, you could. For B, you have a 1/3, you can move up into the exponent. So I have a log x minus log, and y to the 1/3 is the same as the cube root of y. Then I can combine these together by dividing x over cube root y. And that's your final answer. For C, I have a 4 I can bring up front. So hopefully you're noticing this kind of this order of operations as we do these things. We're always bringing that number in the front first, and then we're simplifying with our addition and subtraction. From here, again, it's subtraction. So we're going to condense and make it division. I can also distribute the 4 in to that numerator, and I could have done it in this step as well if I wanted to. So if I do 2 to the 4th, that's 16. A to the 4th over B is going to be the final simplified answer on that one. Okay, and then in this last one you have 2 powers you can bring up top there. So we're going to have natural log of 5y to the 6th plus natural log of x squared. 5y to the 6th, let's go ahead and simplify that. I can do 5 to the 6th, which gives me a pretty big number, 15,625. Natural log x squared. And then they're added together, which means I can multiply to condense my log. So I'm going to have natural log 15,625 y to the 6th x squared is going to be our final answer. Now you might be thinking, what happens if I have 2 logs that are not the same base? So maybe like a common log and a natural log, or a log base 2 and a log base 3. The simple answer is you can't do anything with that. You cannot simplify them. Our log properties do not apply. Just like our exponent properties, they have to be the same base for any of these rules to follow as we simplify. So make sure you always have the same base when you're applying these properties. Okay. Next, we're going to look at expanding now. Expanding is taking one single log and making it multiple logs. The instructions that you're going to see in the homework in my math lab are going to say take a log and write it as a sum, difference, or product of logs and then simplify. Okay, but again, that just means expand it, write one log as multiple logs. All right, so let's start with this first one. The difference here is we're going to see the division and the multiplication and the powers, and we want to make it look like the beginning of those condensing problems. Now, we want to make it into multiple logs. So if you see division, you want to turn that into a subtraction. Again, you should have the same log base every single time. If you see a power, you're going to move it down in front of your log. Or if you see multiplication, you're going to change it into 2 logs that are added together. So for example, we'll call this guy number 1. Here I have division between the 2 parts that are within my log. So we're going to change that into subtraction. So my first natural log will be what's in the numerator, 2x minus 1. And then instead of division, when we expand it, it changes to subtraction. Natural log of my denominator. Now I do have multiplication here, but I can't separate these from one another, again, because of that minus 1 there. If you did have things multiplied inside the log, if that plus minus 1 wasn't there, we would be able to separate a little bit further. But if you have multiplication with addition or subtraction, you're kind of stuck and you can't do anything else with the problem. So I have no powers to bring down, I have no multiplication that can be expanded, I have no more division that can be expanded, so this is going to be your final answer. Let's look at the next one. Here I have a square root. I'm going to rewrite it as a 1/2 power. And we can actually simplify a little bit here. I can distribute that 1/2 through. So I'm not even using any of my log properties yet. I'm using an exponent property. If I do 3 times a half, I get 3 halves. If I do 1/2 times 2, I'm just going to get y to the first. And if I have 5 times a half, it's 5 halves. Okay. So now these exponents, the 3/2 and the 5/2, I can't bring them down because they only apply to the x and the z. They don't apply to the whole log. So what I need to do first is I need to separate the x, y, and z from one another. And right now they're multiplied by each other. So our log properties say if I want to expand multiplication, it's going to change to addition. It's going to become natural log of x to the 3/2 plus natural log of y. Notice I'm putting a natural log in front of every term here when we expand, or whatever log base I happen to have, plus natural log of z to the 5/2. Now I can take that 3/2 and bring it down in front, and the 5/2 and bring it down in front of their respective logs. So I'm going to have 3/2 natural log x plus natural log y plus 5/2 natural log z. And that's our final answer. So you notice we're doing these things in the opposite order from what we did with our condensing problems. The very last thing we're doing in these problems is bringing those exponents down, versus when we were condensing, the very first thing we did was bring that exponent up. So these are just the opposite order of one another. They're kind of like inverses. All right, let's look at the next one. Again, I have a square root, so I'm going to change that to a 1/2 power. So 4xy over z to the 1/2 power. Okay, so the first thing I can do is I can take everything to the 1/2 power that's inside here. Again, this is just using one of my log, well, my exponent properties, I guess. 4 to the 1/2 power, that means square root of 4, and that just gives me 2. X to the 1/2, y to the 1/2, z to the 1/2. Okay, and now I can expand all this. The 2, the x, and the y are all multiplied together, and the z is divided. You can do this all in one step if you want. It's all going to be a log base 10 or a common log here. It's going to be log 2. Multiplication changes to addition. So plus log x to the 1/2 plus log y to the 1/2. And then because I have division now, it's going to be minus z to the 1/2. My last step here is I can bring any exponents down in front. So I'm going to have log 2 plus 1/2 log x plus 1/2 log y. Oop, I forgot my log there. Minus 1/2 log z. Okay. All right, and I ran out of room for my last one, so let's move that down. Give myself some space here. You're going to notice with these problems, anytime something's in the denominator, that log will end up having a subtraction in front of it. And anytime something is in the numerator, that log is going to end up having a multiplication or an addition in front of it. Okay, so the next one. I don't have anything I can do with my exponent properties here. I can't distribute a 3 or a 4 through again because I've got addition and subtraction inside those parentheses. So the first thing I'm going to do is I'm going to separate it. Everything in this problem is a log base 2. Make sure you carry that through. I'm going to have a log base 2 of x squared. Then, because that's multiplied, I'm going to have plus log base 2 of x minus 1 to the 3rd. And then because I have division, it's going to be minus log base 2 of 2x plus 1 to the 4th. Then I can take my powers and I can bring them down in front. 2 log base 2x plus 3 log base 2x minus 1 minus 4 log base 2 2x plus 1. And the only other thing that I can maybe look at is I've got multiplication here, but again, because there's also a +1 inside that log, I cannot separate that any further. So this would be your final answer. So you want to check at the end of these problems for any multiplication that's left, or any division that's left, or any powers that you can bring down. If you don't have any of those, you know that you've expanded completely. And the same thing with condensing. You want to look for any addition or subtraction or any numbers that you can move up into the exponent to make sure that you've condensed completely. So you want to just kind of run through that checklist of 3 things, all 3 properties each time, to make sure there's nothing you're missing that you can condense or expand a little bit further. Okay, so here are some for you to try. All right, so in A, you should have natural log of 3x minus 2 minus natural log of x plus 1. It's really important when you guys are in my math lab that you're putting the 3x minus 2 and the x plus 1 in parentheses. If you don't use a parentheses there, it might look like a natural log of x and then plus 1 as a separate term. We want to make sure that that plus 1 is inside the log, and that's what those parentheses tell us. So be careful when you're typing that in on your homework. All right, in the next one, I have multiplication here between the e squared and the e plus 3. All right, so let's see here. I've got natural log of e squared plus natural log of e plus 3. I have a 2 I can bring down in front. 2 natural log e plus natural log of e plus 3. And actually, this one can be simplified a little bit further. So I want you to remember that natural log is a log base e. Okay? I'm going to keep this one the same. If I have log base e of e, this was one of our properties, if I have a log base and a power of the same base, I can cancel those out. So this log base e of e, that whole thing just simplifies to that power of 1. So it's going to be 2 times 1, running out of space, plus natural log e plus 3. I can't do anything with this term because of that plus 3 there. If it was natural log e, I could simplify a little bit further, but the final answer on this one is going to be 2 plus natural log e plus 3. So that one just had a little bit of review from our previous lesson. Okay, let's look at the next one. Here again, I have multiplication, so we're going to change it into addition. So it's going to be log x to the third plus log 3x minus 4, keep that in parentheses, to the fifth. Then my 3 and my 5 I can bring down in front to make it 3 times log x plus 5 times log 3x minus 4. And then you can't simplify any further than this because that 3x has that minus 4 in the parentheses with it, so that restricts us from expanding any further. Okay, in D, I have division, so I'm going to change it into subtraction. So log base 3 of cube root 4x plus 1 minus log base 3 of 4x squared. Okay. Then I have a cube root, which remember is a 1/3 power, so I can bring that down in front. And then that term is expanded completely. I can't do anything with that 4x again because that plus 1 is in the parentheses with it. Now, the second term here is a little trickier. That squared applies only to the x, not to the 4. So I need to separate these from one another first. So I'm going to split this into 2 separate logs. The 4 is multiplied by the x squared, so it's changing into addition. But that minus in front is going to apply to both of these logs. So it's going to be minus log base 3 of 4 plus, because it was multiplication, log base 3 of x squared. Then you can distribute your negative in. So keep that first term the same. It'll be minus log base 3 of 4, and then minus, I'm going to bring that 2 down in front now, 2 log base 3 of x. Remember I mentioned earlier, if something is in the denominator, let me get my highlighter here. If something's in the denominator, ultimately it's going to have a minus in front of it. That 4 was in the denominator, and the x squared was in the denominator. It's going to have a minus in front of it. Some people will sometimes get confused with this because that 4 and x squared are multiplied together, but technically they're both divided by that, or they're divided into that cube root of 4x plus 1. So because they're both in the denominator, they both end up with that minus in front of it ultimately. So you can either separate them into two different pieces with the minuses first, or if you change it to addition, you just need to remember to distribute the negative in at the end. So be careful with that one. That's probably the trickiest thing about some of these problems, is when you have multiple things in the denominator. Okay. All right. In our next set of problems, we're going to be evaluating a log. So here we have logs that we can expand. And again, this is just review now from what we were practicing a moment ago. If you have multiplication, you're going to change it to addition. If you have division, you're going to change it to subtraction. And if you have a power, you're going to bring it down in front. So what we're going to do with these problems first is we're just going to expand them completely. And then we'll worry about the evaluating part in a moment. So here I have y times z. So I'm going to change it to addition using my log properties. Okay, now is where the evaluating piece comes in handy. If I've expanded completely, I should be able to do some substitution based on my given pieces of information. I'm given in this problem that log base 5 of z is equal to 3. Well, I have that right here. Log base 5 of z is 3, so I'll just replace it. And log base 5 of y is 2. Log base 5 of y is 2. 2 plus 3 simplifies to 5. So when we're evaluating, you're expanding completely and then substituting your given values in. These are meant to be problems you're doing without a calculator. All right, so in the next one, I have division. So that's going to change to log base 5 of y minus log base 5 of z. Log base 5 of y evaluates to 2. We were given that. Log base 5 of z was 3. 2 minus 3 gives me negative 1. Okay, let's look at number 3. I have multiplication first, then I'm going to change to addition. Log base 5 of y squared plus log base 5 of z to the third. Then, before I substitute, I can expand a little bit further. I have powers that I'm going to bring down in front. So it's going to be 2 times log base 5y plus 3 times log base 5z. If you tried to plug 2 and 3 in this step and then square them, you would end up getting a wrong answer. The biggest mistake that people will make in these problems is trying to substitute too early and not expanding the problem completely. So you want to make sure before you substitute, you don't have any more powers you can bring down, or any more multiplication that you can separate into separate logs, or any division that you can separate into separate logs. So now I have 2 times log base 5 of y was 2, and 3 times log base 5 of z is 3. 2 times 2 gives me 4. 3 times 3 gives me 9. Final answer here is 13. Okay, let's look at the next one. Again, I have multiplication, so we're going to change that into addition. Log base 5 of 125 plus log base 5 of y to the 7th. I can bring the 7 down in front, and then that term is expanded completely. Now this one's going to be a little bit trickier. I have log base 5 of 125. This is one that you can evaluate in your head. You can also use one of our log properties. So one way to think about it is 5 to what power gives me 125. Or you could write 125 as 5 to the third power. And then this log property, remember from the last lesson, tells us if we have a log base and a power of the same base, they cancel, and they give me 3. 7 times log base 5 of y we were given is 2. So I have 3 plus 14, which gives me a grand total of 17 is the final answer for this problem. Okay, let's try a couple more together here. In this problem, we're given log base a of 20 is this decimal, and log base a of 5 is this decimal. So at the very end here, you'll need a calculator to plug these numbers in, but remember the goal first is to expand completely. Now, if we see something like log base a of 100, we need to figure out how to write 100, how to expand it in terms of 20 and 5. So you want to ask yourself, well, how does 100 relate to 20 and 5? Well, 100 is 20 times 5. And if I write it as multiplication, we can use our log properties. We can expand it into 2 logs with addition. It's going to be log base a of 20 plus log base a of 5. Log base a of 20 is 1.4406. Log base a of 5 is 0.7740. And then you can add those together in your calculator. I'm just going to do that off to the side here. 1.4406 plus 0.7740. We get 2.2146 for our answer for that one. Okay. Number 2. I have log base a of 4. Again, we have to figure out how does 4 relate to 20 and 5. Well, 4 is the same as 20 divided by 5. And if I can write it as division, I can use my log properties and expand into a subtraction problem. Log base a of 20 is 1.4406. Log base a of 5 is 0.7740. And then we're going to subtract. Okay, so in our calculator, we're going to do 1.4406 minus 0.7740. We get 0.6666 is the final answer for that one. Number 3, let's expand it. I have 5 to the 3rd power. So we can make that, actually, let's just kind of do this all at once here. We're going to move that 3rd power down in front. Make it 3 times log base a of 5. And then log base a of 5, that was one of our given pieces of information. So it's going to be 3 times 0.7740. So in your calculator, 3 times 0.7740, you get 2.322. And then finally, let me circle all my answers here. Number 4. So I have this square root. Remember, we want to think of that square root as a 1/2 power. And we're going to bring the power down in front. And log base a of 20, that was a given piece of information. So I'm going to have 1/2 times 1.4406. And that's going to simplify to 0.7203. Okay, so here are a couple for you to try. Okay, so in number 1, I have natural log of 5 times e, which means I can separate that into addition. Natural log of 5 is 1.61. Natural log of e, again, we did that earlier. You can think of that, let's write it off to the side here, as log base e of e to the first, and that log base e of e is canceling and it's leaving you with 1. So you're going to end up with 2.61 is the final answer. In the next problem, number 2, you had division, so you should have changed that into subtraction. You were given log base a of 15 is 2.71, and you were given log base a of 8 is 2.079. And then you can subtract those, 2.71 minus 2.079. Final answer here should have been 0.631. Okay, the last 2 problems in this lesson are kind of a continuation to how we were wrapping up the lesson in the last section 5.2, part 1. We talked about the decibel scale that was a logarithmic scale. We talked about the Richter scale that was a logarithmic scale. The third and final scale that shows up in this chapter is the pH scale. So pH measures acidity of a certain solution, and you have bases and acids, 1 through 14, 7's right in the middle there, and this is how we calculate pH. pH is calculated using a log function. Negative log is a common log, log base 10 of H positive, where H positive is a concentration of hydrogen ions that are measured in moles per liter. So that's something that you do a lot in, obviously, a science class. You may have seen this before. So for example, let's find the pH value for beer that has the following hydrogen ion concentration. So if I wanted to find the pH, it would be negative log, and I'm just going to plug in that value, that 0.00000631. Okay, so I'll bring down my negative, and actually let's just go ahead and type the whole thing in the calculator. So you're just going to use that log button that we practiced last time. It's right next to your 7 button. Okay, so I'm going to hit my negative key, then my log key, and then that big number. 4 zeros, and then 631. And I get 4.199 if I round to 3 decimal places. So it's going to be about 4.2. Usually we give it 2 decimal places if possible. Okay. Would be 4.20 if I round this one, would be the pH. Okay, let's look at the problem the other way. Here I have a pH 7.79, and we're trying to find the hydrogen ion concentration. So we're solving for H+. This is the pH of eggs. Okay, remember this is a log base 10. To solve for something that's inside our log, the first thing we're going to do is get that log alone. So I'm going to divide by the negative first, or multiply both sides by a negative. It's going to make it a negative 7.79 equals log base 10 of H positive. Okay, from there, once you've got your log alone, you can write with exponents. I feel like you guys need to be putting WWE in the corner of your papers. Write with exponents once you get that log alone. So my base is 10. My power is what my log is equal to, negative 7.79 in this case, and that equals H+. You're probably going to leave your answer like this, but you could always type that in the calculator as well if you wanted to. Usually we're just going to write this as a power of 10 because these decimals get so tiny. Okay, so here's one for you to try. It says lower levels of pH indicate a more acidic solution. A pH of ketchup is 3.9 and the pH of peanut butter is 6.3. How much more acidic is ketchup than peanut butter? So what you're going to need to do is you're going to need to find the hydrogen ion concentration of both of these. Okay, so you're going to find it for ketchup and then you're going to find it for peanut butter. And then just like what we did with like our decibel and our Richter scale before, you're going to divide the concentrations of ketchup by peanut butter to see how many more times acidic one is than the other. Okay, go ahead and try it. Okay, so I'm going to start with ketchup. My pH was 3.9 by 10 there. All right, so solving for H, I'm going to divide through that negative first, and then write with exponents. So 10 to the negative 3.9 equals H plus. Okay, then we're going to look at peanut butter. Very similar. This time it's 6.3. You're probably going to notice there's a pattern to these each time. It's going to make your homework problems pretty easy. Divide through the negative. And then WWE, right, with exponents. 10 to the negative 6.3 equals H plus. Okay, finally we're trying to figure out how much more acidic ketchup is than peanut butter. So you're doing ketchup divided by peanut butter. Ketchup's concentration is 10 to the negative 3.9 power. Peanut butter's is 10 to the negative 6.3 power. Again, this is one of our exponent properties. The base 10 stays the same, and we are subtracting our exponents. Negative 3.9 minus negative 6.3. Be careful with that minus negative 6.3, so it's like plus 6.3. It's going to be 10 to the 2.4 power. So it's 10 to the 2.4 power times as acidic. This doesn't have a crazy weird exponent here with our negative exponents, so let's go ahead and type that in. 10 to the 2.4 power is approximately 251. So it's about 251 times as acidic